Lava Sacras, Manobardas i de Cristian, Man Patinka Ruby on Rails. That was good afternoon. My name is Cristian. I like Ruby on Rails. I know a little bit of Lithuanian because my wife is Lithuanian, and she will be very happy when she sees this video. This is my first presentation. I made it a few times before, but it's the first time, well, it's the first presentation I do in public. But despite that, well, first of all, it's my first presentation, so I'm really sorry about what is about to happen. But despite that, I've been attending to conferences, like Ruby conferences, for 12 years at this point, I think. So I've seen the great ones. I've seen Mats, I've seen DHH, I've seen Aaron. That I think I copied a few tricks in this presentation. One thing I learned is that it's a good idea to summarize the presentation in the first 2 slides. No? So this presentation started with me having the crazy idea of going to the biggest Ruby conferences and putting this slide in the biggest possible letters. And the next one is this. Because it's bullshit. Rails scales. I mean, for example, last year there was this thread by Shopify Engineering commenting some numbers they got during Cyber Monday. And they got to 78 million requests per minute. At the peak. That's 1.27 requests per second. And for me, it wasn't particularly surprising. I work at Zendesk, I focus on performance issues, and we do around 2 billion requests per day, which is it's a little bit less, but it's also we're used to this. It's not something crazy. So then I started to think, why? Why is this obsession with Rails scalability or lack of thereof? I mean, literally, this is something that we're talking all the time. Last few weeks, again, in Twitter, there was a huge discussion about that. I don't know if you've been following the little soap opera that we have in the Ruby community, but we had this tweet by DHH, where basically he trolls the whole TypeScript community, dropping it from, I think it's Basecamp. And then this, of course, got the effect that was searched and started a flame war. And because DHH is the creator of Rails, people started to attack Rails, obviously. Well, there was a very, very long discussion, fight, and all this. And I found one tweet that I found very, very smart, saying, every programming community has some deep-seated insecurity they seemingly never get over. Ruby, it scales, damn it. So I started to think more and more, like, why are we always with this discussion? And I have a theory. But to explain this theory, we will need to do some time traveling. Oops. So, time traveling. By the way, this is Doraemon. Oh. Let me go to full screen again. This is Doraemon. Do you know who is Doraemon? No? Okay. Well, mixed responses. So he's a 22nd century, I think, robotic cat. And he has a time machine. But don't worry, we'll talk later about Doraemon. We're going to time travel to year 2010. This is me then, I was in college. And I discovered, I had done a course on PHP, the typical LAMP stack, and I discovered Ruby on Rails. So I decided to try my first Rails app. And this app needed authentication. Authentication is a hard problem. Like just discussing encryption makes me dizzy sometimes. So then I decided, okay, I'm going to really nail this because it's very important. I checked the most important papers. I read all the sources possible, and eventually I found Device. Device is very easy to configure. You know, like I just install a couple of things. You need to run a few migrations, change a little bit your models. That's it. It just works. Authentication is a hard problem. A lot of years after I became a tech lead for the authentication and security team at Zendesk, and it's hard. It's also something that if you mess up, very bad things happen. But for 22-year-old me, it didn't feel like that. It feel like, oh my God, I'm such an incredibly good engineer. That's the first step. Next, to continue, we need to go again to some time traveling. I think I'll do it like this. To some time traveling, now to the year 2012. That's the year I met Mats. I'm very proud of this picture. At the time, I was CTO in a company called Playful Vet. CTO stands for Chief Technical Officer and also for the only engineer in a very small company. So I had to do everything. And ironically, we were never very successful money-wise, but we were very popular with teenagers mainly. So we had to scale, which is the topic I'm talking here. Scaling is a hard problem. So I repeated the same. I said, OK, I'm going to do the same as I did with authentication. I'm going to do a deep investigation, check everywhere around and all that. And of course, I found this magical gem called active scale. I read the documentation very thoroughly. I really recommend. And then I finally decided to go for the parameter sufficient but not too much. So scale, relational scale, sufficient but not too much. I would totally not recommend the parameter go bananas because you may have problems with that. And that's it. I deployed to production, and everything was beautiful and nothing hard. Yeah, I think the next one will have a lot of time. Well, obviously, no. Active scale doesn't exist. This is, I think I took active record repo. I just changed the title using Google Chrome. My point is that scaling is a hard problem, but it's a hard problem that feels hard. There is no like a free lunch like you get with device and with a lot of Rails goodies like active record, for example, that give you a lot of power without you understanding much what you are doing. My conclusion here is that the problem is not that Rails doesn't scale. It's that Rails is so good in so many things that one of the few problems left for you to solve is scaling. So far, you've had like such a nice learning curve that when you get to a problem that is not solved, prepackaged in Rails, other people don't know what to do. Okay. Before moving on to the techniques that we use for scaling a big application, I would like to give some general comments on the presentation. We're not going to get very deep into anything. This is just an introduction to the problem of scaling. I'm going to offer general ideas illustrated with the issues we face scaling to a significant degree. The reason for this is that there are no silver bullets. When someone tells me, hey, I have a Rails application, it's very slow, I say, OK, I don't know. I don't know what's happening. Very commonly, it can be database, but there is like a lot of ways that something can go wrong. So it's kind of like Tolstoy said. No, every poorly performing system is performing poorly in its own peculiar way. Next, I want to introduce you to the size of the problem that we have at Zendesk, the amount of data and requests. Zendesk is a customer support company. We do tickets. Like, for example, if you complain about something for some of our customers, typically this generates an object in our database. We have over 20 billion tickets. So if you divide by the amount of people in the earth, you could assign 2.5 tickets to each human, including babies and very old people, and then everybody will have a lot of tickets. Moreover, there is growth. Around a third of the data that we have at Zendesk was created in the last year. This has implications in our systems, obviously. We have multiple databases like key value stores and all that, but our relational database, that is the one that is mostly used with the Rails monolith, is over 400 terabytes. Moreover, this is very unevenly distributed. We have one table, which it tortures me every night, which holds an incredible amount of rows. We have in one chart, one table has trillions of objects. That's a very hard table to operate with. Okay. Next, we're going to start talking about techniques. And one that is like maybe the most important is monitoring. Why is monitoring so important? Well, because you cannot fix a problem you don't know you have. The endpoint, imagine you make a change and suddenly an endpoint that took 500 milliseconds now is taking 5 seconds. You wouldn't even notice, most probably. If you're not monitoring, you won't know. Eventually, you will know because customers will start complaining. But sometimes, customers can deal with a lot. A lot of times, customers will just leave. One of the things I hear often is that monitoring is expensive. That is true, particularly at scale. But we performance engineers, we have an advantage that is also common when you are doing, I don't know, exception tracking. We can sample. Sampling is very, very useful when managing performance. A lot of times, even a 10% slice, which is good enough to understand how an endpoint is behaving. This evolves into error budgets. That is a concept that we use at Zendesk very much, and I think it's not very common, particularly in smaller companies. The idea is setting an error budget for latency. Typically, when someone thinks an error budget, they say the 5 nines, no? This endpoint return 200, 99.999% of the time. Well, why you don't define one for latency, for the amount of times the endpoint was slow? This is a screenshot from a real dashboard we have at Zendesk. At the left, you have the uptime, the typical error budget, the amount of times that we return successfully. But in the middle and in the right, we have what we call the error budget for latency. So, for example, ticket create in the middle, returned in an acceptable amount of time, 99.9762 all the times. You may be thinking that this is arbitrary, and you will be absolutely right. You need to define an arbitrary limit. But that's still useful. It's useful to have a North Star. First of all, because it helps you to understand when the endpoint degraded too much. And second, well, yeah, that's actually why it's important. Next, we'll go to the thing that most of people believe that is the only work we do when we work in performance, that is database query performance. And you would kind of be right. Most of my time, I spend it thinking about why is this query slow, how we can break it, how we can go somewhere around this data fetching. But I don't want to talk exclusively about this. Originally, this presentation was titled Beyond N+1. Still, I will give a few very basic ideas. Use database indexes, please. You will be surprised how many times you find applications that are not using them. But with database indexes, sometimes you find funny situations, like particularly with very complex tables, with a lot of objects, sometimes database engine won't pick the right one. Use something called explain, analyze, to see what's happening exactly with that query. This is very common, particularly if you have a very complex query, it can get complicated. Next one, and this is probably one of the two star techniques that we use at Zendesk, and this is very common in big companies, is called sharding. So the idea is that, hey, you have a lot of data. What if you use multiple databases? So you go, you break your big database in smaller ones. Some businesses have a use case that works very well. For example, as at Zendesk, I don't know, customer one doesn't care at all about the data of customer two. So it's very easy to just break it into different tables. In the example here, they use mod 5. That's one way. Eventually, what happens is that you want to have an automatic way of sharding and then manually fixing. Like, for example, you have a huge customer, you give him its own shard. Next on the button, and this is something super common in Active Record, is what I call greedy selects. So you have, imagine, a query called user.where ID bigger than 42. This is doing a select star. You are selecting everything, all the columns. Sometimes it happens that you have this endpoint that is very lean, and you only want the ID, you only want the title maybe, but unbeknown to you, you are fetching gigabytes of text, gigabytes of blobs that are completely useless. This is something that happens from time to time, that you find because people use Active Record without understanding a lot what's happening under the hood. And optimizing that using just .select is a pleasure. This is a real optimization we did on an endpoint, and I think you can guess when we release the optimization. Finally, I want to go back to the idea of complex database queries, because sometimes people write this crazy query, runs it a few times on dep, and say, hey, it's not that slow, that's fine, good. The problems with database queries that are complex is that they have very high variability, meaning that 95% of the time they will be okay, 4% of the time they will be slow, 1% of the time they will cause a database meltdown. You don't want to be a query like that. So please focus on P99s. That should be another North Star to follow. Next, another technique that is very common, and it's pretty cool, is caching. But I don't want to focus on the typical case of caching of, hey, I have this data that I access very often, so I am going to put into the smaller, faster storage. I want to talk about some techniques that are around caching. One that we use often is called write-through caching. This is very useful for the normalized objects. Imagine you have this endpoint that makes this very complex calculation that you need to do on the fly. Why? Why you need to do it on the fly? Why instead of calculating every time that you have a read, why you don't pre-calculate in the write? One example for this will be you have an application that returns certain objects. with a series of filters. Those filters are static. The customer cannot customize them. Why not prepare the calculation? Again, this is only if those filters are built in a way that are very hard to query into a relational database. But the change in between running a complex query on each read and just returning objects from Redis, for example, or from a key value store is incredible. This an optimization that we did with that. In this case, there was a side load on one of our main endpoints on Ticket Show. We moved from 40 milliseconds, that side load alone, to, well, 5 milliseconds. And you may be thinking, you are talking all this for just 35 milliseconds? I mean, this doesn't sound like a lot, but at scale, it is a lot. Like, for example, that endpoint, not that endpoint, actually, that side load was being called 50,000 times per day. Multiplied by 365 days is more than 8 full days of computing time. That's a lot of money. Okay? The thing is that caching has trade-offs, and they're complex trade-offs. You're adding complexity. You may be not adding another source of truth, but you are duplicating data in the end. You are reading from a place that is not a source of truth. This means that caching isn't trivial. And then we go back to my special guest of tonight, who is Doraemon. Doraemon is this cartoon that used to be shown in Catalan TV. I'm from Barcelona, every morning. And after thinking a lot about it, I think it's like this incredible fable about software engineering. Most of you don't know what is this, so let me explain you what is Doraemon. So, as I said before, he's a robotic cat from the 2nd century that has millions of futuristic gadgets in his 4D pocket. Basically, he's like a wizard. Anything he can do. Like, he has a little hat that flies. Then he has, I don't know, he can create objects out of nothing. And this pocket is amazing. Anything fits there. Like, literally, here you have him taking out a door. This door allows you to transport. So basically, this pocket is like this kind of messy place where you can find whatever. It's a bit like Redis, no? Said this, why is this a fable about software engineering? Because each episode of Doraemon follows exactly the same pattern, the same formula. Doraemon lives with a Japanese kid in the late 20th century, Nobita. Nobita is this very, very clumsy guy. He's always getting into trouble. The episode starts, Doraemon, please help me. I failed. I don't know, this girl doesn't like me, something like that. And Doraemon eventually says, okay, here you have this machine. It will fix all your problems. And for like 5 minutes in the episode, I think every episode is like 10, it works. Nobita is happy, everything is working. But eventually, there's this temptation. Hey, I fixed my problem, but what if I fix all those things that were not in the specification of the machine, that Doraemon told me not to do, that I don't know what I am doing? In each episode, he eventually misuses the machine and ends up crying with a much bigger problem than he originally had. I think that some technologies that seem super simple tempt us to misuse them. I have a friend that used to tell that don't include any gem that you haven't read the source code. I don't think that nobody does that, including him. But I like it. I like it, his spirit. But for example, one gem that I see used in ways that shouldn't be used, Active Record. I mean, everybody uses Active Record, but everybody misuses Active Record in a lot of ways. So my point would be, try to use technology wisely, understand the consequences of what you do. Next, and this is with sharding, the other thing that is really powerful is called storage. And yes, I'm adding another storage. Now we'll have caching, we'll have the relational database, and a third storage that right now you don't even know for what it is. But first of all, why would you add another storage? Well, as I commented before, we have a lot of data here. Over 20 billion in tickets. Trillions of rows in one table only. So, a lot of data. This can be problematic. How do you get back to this state on the first week of the business that you had like 20 objects in the table and everything was so fast? Well, I can make those tables smaller. I can just remove objects, remove rows out of the relational database. You can add a new storage. The idea would be to move out of the relational database data that is rarely rarely used. You can define a little bit this as you want, or more like as product wants. But let me give you an example. This is how we do in reality at Zendesk. Here you have like a mini Zendesk, you know, a user that has many tickets, and ticket has many events, like an audit log. And after some time, we mark data as ready for archival. At Zendesk, we define it like by default. When a ticket has been closed after 5 months, we declare it as ready to be archived. At the point, we have a background job that removes the ticket and the event from relational database. But we don't totally remove it. What we do is we move it to a specialized ticket storage unit. The most common question I get in this presentation, when I did before, is what do you use for storage? We use it historically. We use Riak, R-I-A-K, but now we are using more and more Dynamo. And I have the dream of someday using Amazon S3, but that has some implications that we won't discuss. Here you will be a bit surprised because you will say, hey, I am losing all the associations from ticket. What do I do here? Well, what we do is we create a new object. Here I call it archive ticket, but basically it's a skeleton of the original ticket. We only keep the most basic data, like associations, so we can keep those associations alive. And then this archive ticket points to the DynamoDB storage, where we can fetch data if we need it. I cannot express how important is this at Zendesk. Literally, most of the data we have at Zendesk is archived. Like here is like 90-something%. Without it, we have like around 9 times more data across all the tickets tables. That's very, very significant. Of course, this has trade-offs. Suddenly, you usually had ticket, and the ticket data was in the ticket table. Everything made a lot of sense. Now, suddenly, you have multiple sources of data, and this may introduce issues on the product. Before, you had used this endpoint called ticket index that returned everything, just making queries against one table. Now, you may decide, hey, maybe ticket index doesn't return all tickets. Maybe it does, but then I need to query 2 storages that are completely different. Literally, they are powered by different technologies. You may decide that change of patterns may be necessary. And we're talking about access patterns. We'll go to discuss product issues. And here is the most important point of the whole presentation. I didn't highlight it before because it's something that it may escape from the scope of most of engineers. But this is product limits. I cannot stress how many times we've regretted not having a product limit years ago. My point is that once a platform gets to a certain size, you no longer understand what users are doing with it. Sometimes you may find ill-intentioned users that misuse it. Sometimes you have users that are using the platform in a very particular way. The point is that you don't know what is happening. And you want to protect yourself against misuse, even if it's well-intentioned. I know product limits may not be sexy. You don't want to talk with a company that's giving you $1 million, say, hey, you cannot do this. You always want to highlight the things that they can do. But the problem is that all platforms have product limits, all systems, because our systems, software engineering systems, run on a physical world. And this may be your final product limit. A database meltdown can completely break you. Please set up product limits. Again, when I'm saying this, I don't mean something extremely strict that would mess with most of customers, something like this. Sometimes when you write a new feature, put a product limit that doesn't make any sense. You will say, hey, 99% of the customers will have max 10. Put 1,000. Eventually, you will be happy with that. The next one is a classic. I call it the incredibly enlarging payload, also known as endpoints that return way too much data. Like, if you've been long in a company, you've probably seen that. Like, you wrote the endpoint a lot of years ago, and it was returning like 4 attributes per object. It was really, really nice, really lean. But then one feature, another feature bloat. And suddenly this endpoint is super slow because it's returning like 40 different attributes per object. You're sending through the internet megabytes and megabytes of data. Well, this obviously has implications. The endpoint has become slower. The complexity has increased. and the payload is just bigger. I mean, sometimes front-end applications have a problem like parsing those huge JSONs. Try to have linear responses. You can use siloed, you can use GraphQL. Yeah. Then the next technique I wanted to comment is breaking down slow workflows. For example, on the read. The idea here seems pretty stupid. Like, hey, I need this data. I can get it by one call. Why would do two? Why would get, because I'm going to have to execute exactly the same logic, but I will have to add all the time in the network, all the time in the middleware. That's literally just slower. The idea here is to help the user. Common thing, you have you are fetching from this huge endpoint and you don't start rendering until the whole response is back. Well, this is time that the user is blocked. The idea here would be to fetch first data the user really needs to get unblocked to start interacting with your application, and then just fetch the rest. Same philosophy applies for using writes. Here you have another example of feature bloat. You know you have an endpoint that has write data, and you're writing A, that was the original point, but then it's B, C, D, you're writing to multiple storages, you're doing a lot of stuff, and that's slow. The point here is to go async. The most common way for this, even based more REST applications follow that pattern, is to move it to background jobs. You know, like you first write A, then you get the response, and then you very typically add jobs to a rescue queue or a sidekick, whatever, and then the sidekick workers process it. That's a good pattern. And eventually this goes up to distributed systems. Like, for example, you can have Kafka queues that are consumed by different applications and write to different databases. That's good. Said this, I live at Zendesk like multiple projects with that target. And one thing that we realized that eventual consistency can be painful. It's for an engineer, it's something you need to get used to think in a different way. However, one thing in my experience I found is that customers can live pretty well with that. A lot of times our PMs were worried, hey, this that was immediate, now it's going to take 2 seconds. Will it be okay? Customers a lot of times are fine with it. Don't underestimate them. Okay? We're getting to the end. I would like to give you with a philosophical advice. It's very easy here. What's the right mindset for a performance engineer? Very simple. You just need to be like Alexander the Great. Yeah, seriously. I don't know if you've heard this story about Alexander the Great and the Gordian knot. Let me explain you very briefly. It was the year 333 before Christ. And Alexander was in war with the Persians, I think, and he was passing by the city of Gordion in what is now, I think, central Turkey. In that town, they had this legend about the Gordian knot, a knot, created by one of the first kings of the place. And the idea, the legend, was that the person that would untie the Gordian knot would become king of all Asia. Alexander famously had imperial ambitions, so he decided to try to untie it. But it was impossible. He spent hours and hours, and he just couldn't. Like, it was even hard to find where the knot started. So eventually, kind of desperate, he took out his sword and cut it. I think, how do you feel about this solution? Because the first times when I heard this story, I thought, well, but that's kind of cheating. I mean, he solved the problem, yes, but that was not how it was supposed to be. Or was it? I mean, he did become king of all Asia, what we believe was Asia at that point. But then I realized, why I am putting to myself this requirement of the knot need to be untied in a clean way, keeping the structure of the rope. That's something I literally made up. I think this is a very common problem for software engineers, that we tend to have a very organized mind, try to set up everything following certain rules, and we try to not to break them. And it makes sense. I mean, a chaotic system is impossible to fix or to operate with. But sometimes the only way to move forward is using unconventional solutions. We shouldn't be scared of unconventional solutions. We should be bold. This is very important for a performance engineer. Finally, performance work is about trade-offs. I very strongly believe that there is no such a thing as a perfect system. There is a system that fits perfectly certain needs, but there is no system where data is completely denormalized, it's incredibly fast. That just doesn't exist. It doesn't make sense. I believe that pursuing excessive perfection is counterproductive. I've seen colleagues trying to build these perfect systems for years just to get burnout and not being able to deliver. However, the good news is that I believe that in the Ruby community, we know this very well. We are a community that optimizes for developer happiness. I mean, just look at Matt this morning. He literally told it. It's like it's a language that is made for is created to make us happy. And I would like to finish with this quote by Matt. Yeah. I believe that the purpose of life is, at least in part, to be happy. Based on this belief, Ruby is designed to make programming not only easy but also fun. Thanks.